Section 14.8 on Lagrange multipliers. So in this section we're going to find the extrema, or in other words the minimum and maximum for some function. And that, you might say, we've already done in section 14.7. But in this section there's going to be an extra constraint. And a constraint would be like, imagine a football, and then you need to have the biggest soda can that fits inside the football. So we're finding the maximum of the soda can size, but the constraint is it has to be inside of a football. So there's going to be a constraint equation, and with that equation you could just move everything to one side and set it equal to 0. So the constraint is going to be called G, and once you move everything over to one side, it's set equal to 0. So here's what Lagrange's theorem says. If the function has a minimum or a maximum at some particular point, then there is a number or a constant, and that is called lambda. So this is a lambda right here. So this is going to be an actual number, square root of 3 or something like that. We'll find out in a moment. So there is a constant lambda, so that the gradient of f is equal to a constant multiple of the gradient of g. And that's it. Which is actually pretty interesting because the gradient, you remember, is the fastest way up or the fastest way down the function. If you're at some particular point and you want to go up the hill as fast as you can or down the hill as fast as you can, the gradient is going to tell you which direction to go. So these are basically saying, well, if you have one vector that's a constant multiple of another, that means they're both pointing in the same direction. One can be longer than the other, but as far as the direction, they're both agree. They're saying, do you want the fastest way up or fastest way down? They both agree and they say, go that way. Okay, so this lambda is called the Lagrange multiplier. Now, another way to break it down is gradient means take the derivative with respect to x, and then those two have to be equal. Take the derivative with respect to y, and then those two have to be equal. Well, if you look at this, this can have x's and y's in it, this can have x's and y's, and there's also a lambda, which means we have 3 variables, which means we have 3 equations. 1, 2, and 3. So we also need that constraint equation to help solve for x, y, and lambda. So the good news is this is very little calculus at all. The funner part is we're going to get to do a bunch of algebra because we're going to have 3 equations and 3 unknowns. So the calculus part isn't going to be too bad. The algebra is going to be a little more challenging. And then for example number 1. So with number 1, we'll start off simple, just a nice easy function. The function is just x times y. And the constraint is, so this is a circle with radius 3. So basically this is a function that's up in the sky in 3 dimensions. And this is saying walk around the xy axis, walk around a circle of radius 3, looking up to the function, or down if you're looking for a minimum. So look up for a maximum, down to a minimum, but you have to walk along the circle of radius 3. Okay, so for one thing, this is supposed to be set equal to 0. So you could have x squared plus y squared and then subtract 9 so it's set equal to 0. And once it's set equal to 0, that's what you call the g function, the constraint. Okay. Now we need to do this part. So take the partial derivatives with respect to x, So take the derivative with respect to x for this one, which means this is going to be a 1 times y. And also take the derivative with respect to x. This one is going to be 2x. And then in a moment, I'll set those equal to each other with the lambda. Now take the derivative with respect to y. So this one would be 1 times x. And take the derivative here, which is going to be 2y. And now do the lambda part. So this first equation is going to say y equals 2x with a lambda. And this one's going to say x equals 2y with a lambda. And the other equation that we're going to need is this one when it was set equal to 0. Or you could just say this equation right here. X squared plus y squared equals 9. So I'm going to use substitution over here. This one's already been solved for x, so I can take this and plug it in for x right here. So it's going to look like y equals lambda times 2, and then replace this x with lambda times 2y. And then notice that this has a y and this has a y. So usually I would say don't divide by y. Instead, it would be better, let me just rewrite the right side, clean this up a little bit. There would be 4 lambda squared. So usually I would say do not divide by y because we don't know if y equals 0 or not. So to avoid that, you could just subtract this y. And then you could factor it. So it's going to leave a y gets factored out, and then 4 lambda squared minus 1. And then set this one equal to 0, and set this one equal to 0. Now, if y equals 0, then you plug that in over here, and then that means that x is equal to 3, plus or minus 3. But we also have to take consideration of these. If y equals 0, that means that lambda times 2x equals 0. Also, if you plug in y equals 0, then this equation means x has to equal 0. And if x equals 0, the same times y equals 0, that is not a solution in here. So this is not possible. So this is all we have. And then you could add 1 to both sides. Going to need to continue over here. And then lambda squared is equal to 1/4. Lambda is equal to, take the square root, plus or minus 1/2. Now take that result and put it right here and right here. So that means that y is equal to, so I'm using this equation, substitute plus or minus 1/2 times the 2x. So that means y is equal to plus or minus x. And then you could do the same thing here, and it's going to say x equals plus or minus y, which is the same thing. Now, that just says x and y are equal to each other, but what do they actually equal? So substitute y equals x in here. So this equation becomes x squared plus, and then plus or minus x gets squared equals 9. So that means it's x squared plus x squared, or 2x squared, equals 9. And then I need a new paper. So x squared is equal to 9 over 2. And then take the square root, so it's plus or minus 3 over the square root of 2. And back over here, we saw that y is equal to the same thing with plus or minus. And then the only other thing to do is find out what z equals. So then substitute those numbers in, plus or minus 3 square root of 2 and plus or minus 3 square root of 2. So that's going back to the original function. So substitute those in right there. So that means just multiply them. So this is actually 4 points because you need to take both positive, both negative, one positive, the other negative. So there's actually 4 points. Oh, I forgot to multiply them. I was paying attention to that. So I need to multiply these. So that's going to be 9 over 4. So there's extrema at, and then I think I'll just get the decimal. So 3 divided by the square root of 2. So it's going to be plus or minus 2.121, plus or minus 2.121, and then 9 divided by 4, 2.25. Now to see are these minimums or maximums, let's take a look at the graph. Okay, so here's the graph of the function z equals x times y. And as you can see, there's some places above the xy plane where it really goes up, and down below the ground there's some places where it goes very low. So we should have some minimums and maximums. Then I said what you could do is walk around the xy plane, walk around the circle, x squared plus y squared equals 9. So next I'm going to graph that, and it's going to graph a cylinder, which is basically like walking around the circle. So there's the circle, and then you look up to the function, and where the pink and the black part meet, there's going to be a maximum. There's going to be another maximum over here, and down here there's going to be a minimum and a minimum over there. So then I took our decimal answers, and when all three are positive, that is a maximum point right there, point A. And then point B, when z is a negative, then that's a minimum down here. And part C and D. So then there's 2 minimums, that would be B and D, and 2 maximums, that would be the A and the C. And now for example number 2. Notice that this one is a function of 3 variables. This one's a function of 3 variables. So we're going to need to do the partial derivatives with respect to x, y, and z. This one is supposed to be put equal to 0, so the g function is going to be x squared plus 2y squared minus z minus 1. All right, now the derivative with respect to x on the f function. So that would be 1 times y squared, so that's just y squared. And for the g function, the derivative with respect to x is just going to be a 2x. Now moving on to the derivatives with respect to y. So the derivative of this would be 2y, and the x will just stay there, so it's going to be 2xy. And for this one, the derivative is going to be 4y. Then on to the derivative with respect to z. So here, that's just going to be a 1. And for this one, it's going to be a negative 1. Okay, so now we use the lambdas. So the first equation is going to say y squared is equal to lambda times 2x. Next, we're going to have 2xy equals the lambda times 4y. And the bottom one is going to say 1 equals negative 1 times lambda. So that would mean that lambda equals a negative 1. That turned out to be pretty nice algebra right there. And then we could substitute that here and here. And I think I'm going to need some more space over here. So if we substitute the lambdas here, this equation right here is going to say y squared is equal to negative 2x. And then we could solve for x. So x is going to equal y squared over negative 2. And then we could substitute that right here. So that would say 2 times, and now replace the x with negative y squared over 2. And then times a y. And then equals, replace the lambda with the negative 1 times 4y. So over here, the 2's are going to cancel. This is just going to be negative y cubed equals negative 4y. So I think I'll put the y cubed on the right side. And then I could even factor it. Factor out a y. And so the three solutions for that would be y equals 0, y equals a positive 2, and y equals a negative 2. Oops, I forgot my negative. Negative 2. And then what does x equal? So let's see. I suppose we could substitute those values into this one. I was just trying to see which equation is simplest, and I think it's this one right here. So, or even this one. That's even better. So then just substitute those y values. So for y equals 0, then we're going to get x equals, so substitute a 0, and of course that's going to be 0. And then if y equals, now it actually doesn't matter if I put the plus or minus 2, because it's going to get squared either way. So y equals either a plus or minus 2, then x is equal to negative of plus or minus 2 gets squared divided by 2. And then that would be, so that's going to be a 4 divided by 2, so it's going to be negative 2. Okay, so we got when x equals 0 and y equals 0, and then when x equals a negative 2, and y is equal to either a positive or negative 2. Now we need to find out about z. So none of these have z in them, so we're going to need to go back to this equation right here and substitute in for x and y, and then find out what z equals. So using this equation, x squared plus 2y squared minus z equals 1. And then substitute in these points. So if you use 0, 0 for x and y, that would be 0, that would be 0. And then I would just leave negative z equals 1. So z equals negative 1. And I can go ahead and use the plus and minus all at once because it's going to get squared anyway. So negative 2 for x plus or minus 2 for y. And then that would say negative 2 gets squared plus 2 times either plus or minus 2 gets squared minus z equals 1. So this is a 4. That's a 4 times 2 is 8. And so this is 12. So subtract 12 from both sides. 1 minus 12 would be negative 11. So z equals 11. So our final points are 0, 0, negative 1. So 0, 0, negative 1. And then also a negative 2, either a plus or a minus 2, and z is an 11. Now, we still need to find out, are these minimums or maximums, and we have to find out what the function value is. So we need to go back to the function right here, and then substitute in these, and then we still need to figure out if it's a minimum or a maximum. So f of 0, 0, negative 1 will be x times y squared, and then plus z. So that equals negative 1. And f of negative 2 plus or minus 2 and an 11 is going to be the x value times the y value squared, and then it's plus the z value. So this will be 4 times negative 2, so that's negative 8. With an 11, that's a 3. So this is bigger than this. So it seems that this is a maximum and this is a minimum. So finally we've got a minimum. X is a 0, y is a 0, z is a negative 1, and the function value is negative 1. And then for maximum, so this is the maximum value 3. So that would be negative 2 plus or minus 2 for y, 11 for z, and then the function value would be 3. So for the third and final example of this section, find the extrema for this function. And then you're saying to yourself, self, didn't we already do this? Well, let's make it a little more fun. What if there's two constraints? Emphasize 2. And the two constraints are that z has to equal x plus y, and also x squared plus 2z squared is equal to 1. So basically it's saying find the minimum and maximum for this. So this would be like maximize a soda can that's going to fit inside a soccer ball. And there's another constraint that you have to do it while standing on 1 foot. Sweet. Okay, so this I'm going to call the G constraint, and I'm going to call this one the H constraint. So everything needs to be put on one side. I'm just going to subtract the Z. So G is equal to x plus y, and then subtract Z from both sides. And then I'm going to call this one H. And I'll just subtract the 1 so that it's set equal to 0. So x squared plus 2z squared, and then subtract 1 from both sides. So basically, Lagrange says the gradient of the original function is going to equal a constant times the gradient of this one. Now, if we have another constraint, we then need to go plus a constant times the gradient of this one. So instead of using Greek letters, I'm just going to use an a instead of lambda. And then plus b times the gradient of the h. Okay, now start finding the partial derivatives. So the derivative of f with respect to x, that's just going to be the number 3. The derivative of g with respect to x, so that's just going to be a 1. And the derivative of h with respect to x, that's going to be a 2x. So after I'm done with derivatives, this one's going to say 3 equals a times 1 plus b times 2x. But let's go on to the derivative with respect to y. So for this one, that's just going to be a negative 1 for the g function. The derivative right here is going to be a 1. And for the h function, it has no y's in it, so the derivative is 0. Good, that cuts down on algebra. And now take the derivative with respect to z. So for this one, that'll be a negative 3. Then go on to the g function and take the derivative with respect to z. So that's going to be a negative 1. And for this last one, h with respect to z, that's going to be 4z. Okay, now set up the equations. So this first one will be 3 equals a times 1 and b times this. So 3 equals a times 1 plus b times 2x. This equation is going to say negative 1 equals a times 1 plus b times this one. And this equation is going to say negative 3 equals a times this one plus b times 4z. All right, now we need to solve for a and b and x and y and z. Well, this equation right here, that's pretty simple. That one means a equals negative 1. Then we could take that negative 1, substitute it right here. So then we would get 3 equals negative 1, so substitute that for a, plus b times 2x. So that means that b times 2x, add 1 to both sides, is equal to 4. Or you could divide both sides by 2, so b times x is equal to 2. Now we could also take that negative 1 and substitute it right here. So this equation is going to become negative 3 equals, this would be negative 1 times negative 1, plus b times 4z. And then subtract 1 from both sides, it's going to leave negative 4 equals b times 4z. And then divide by 4 and divide by 4. Sorry about that if it got off the screen. So divide the 4s, those 4s are gone. So now we have this to work with and this to work with. Well, it just so happens that each one of them has b, so I could solve for b. But the other thing is, I need that this equation is true and also this equation is true. So these two also have to help me to solve for x, y, and z. So I think what I'm going to do is this one has x and z in it. So what I could do is solve for z. So that's just going to be negative 1 over b. Solve for x, 2 over b, and substitute those into this equation. So for the next page, I'm going to be using x squared plus 2z squared equals 1. And from this one, that z is equal to negative 1 over b. And from this one, x is equal to 2 over b. Now, substitute those in here and here. So this one is going to be squared. So when you square this, it's going to be 4 over b squared plus 2 times, and then square this, which is going to be 1 over b squared equals 1. So I can actually add these together. They have a common denominator, so that's going to be 6 over b squared is equal to 1. Then multiply both sides by b squared and take the square root. So b is equal to plus or minus the square root of 6. All right, now we could substitute that in right there to find out what z equals, and right there to find out what x equals. So then z is equal to negative 1 over the b, so plus or minus the square root of 6, and x is equal to 2 over plus or minus the square root of 6. And the only person we're missing is y. So go back to the original problem, and it says also z has to equal x plus y. So now use that z has to equal x plus y, and we've got z is equal to, so this negative doesn't really matter because this is saying you have to use both plus and minus. So plus and minus 1 over the square root of 6. And for x, plus or minus 2 over the square root of 6. And then subtract this from both sides. So then it's going to be 1 over square root of 6 minus, so, oh boy, actually, there's going to be 4 answers because we have to do plus, 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 minus, 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 and minus, plus. I might need to get another stack of paper. Okay, so let's see, if these are both positive, I would need to subtract and then get negative, so y could equal negative 1 over the square root of 6. If they were both negative, then I would need to add this to both sides, in which case it would be y equals positive 1 over square root of 6. And if this one was positive and this one was negative, I would have to add this one to both sides, so then I would get 3 over the square root of 6. And then if this one was negative and this one was positive, then I would need to subtract this and I would get negative 3 over the square root of 6. That's a lot more answers than I thought we were going to have. Okay, so then our points are, how can I summarize this? Well, I can summarize that by saying plus or minus. I could summarize that by saying plus or minus. These both have plus or minus. So then so x needs to be plus or minus 2 over the square root of 6. And y, we're going to have to do two possibilities, that it's this possibility, so plus or minus 1 over the square root of 6. And z has these two possibilities. And then the other is when it's plus or minus the square root of 3. And then z plus or minus 1 over the square root of 6.